Hello guys, in this tutorial I have explained the step-by-step procedure to simulate this airflow inside a room that is equipped with an air curtain. If you are new to Ansys Fluent, I suggest you to follow the tutorials that are suggested above here. And if you are already familiar with this Ansys Fluent, you can go ahead. In the geometry phase, I have created a geometry that corresponds to a room that is modeled as a 2D geometry. I have created two inlets for air conditioning system, one at here and another at here. So let me show you that dimensions, that is H5 and 6. 2.5 inches has been kept as the inlet size for the air conditioning ducts, and here I have an outlet for the air conditioning system, that is V15, that is 12 inch. 12 inch is given as the outlet for the air conditioning system. So here these are the two inlets, and through these two inlets the cold air will be getting into the room, and after cooling that room it will be recirculated to the compressor through this outlet. And then coming to the entrance of this room, here we have an air curtain. This is the inlet of that air curtain that is inclined at some angle A11. So when you see that angle, it is 75 degrees to the vertical. The angle from the horizontal is 90 minus 75. So this is the angle of this inlet of the air curtain, from which the air at high velocity is blowing in order to create a recirculation zone here, so that that will be acting as an air barrier, just like a virtual door. When the air is getting in through this air curtain, it will be dumping the room, so that should be recirculated through some way. There is also an intake port for this air curtain, that is this particular port. So this is considered as an intake port for that air curtain. And finally, this is the interface where the room is having an atmospheric interface. When the time goes on, the room temperature will be getting down because of the refrigeration system that we have kept here, and this will be acting as a barrier, so that there will be a difference in temperature between the inside room and the space that is outside the room. And the main objective of the simulation is to compute the heat loss or the heat leakage that is happening even if we have this air curtains. So that is estimated by using the heat flux through this particular boundary. If there is some heat flux or heat flow through this boundary, that means that the heat is entering into the system and the cool air that is inside the room is leaving out of the system. So that is a loss here. So that is to be estimated. And I have created this geometry and I have converted that to plane, and in the modeling we have only one surface, so that is created by this option concept surface from sketches. And after creating this surface, we have to create the mesh. So for that we have to get into the mesh module in Ansys Workbench. Okay, in the mesh module we have to make sure that we have given all the name selection properly to all the inlets, so that we can give the proper boundary conditions in the Fluent. So we have two inlets. These inlets should be named appropriately. Here I have named that as inlet 1 and inlet 2. These two are the air conditioning systems air duct inlet, and here I have named this surface as outlet, and this will be acting as the outlet for this air conditioning system, and this is the inlet for air curtain. Particularly in this simulation I have kept this air curtain name here, so that this will be acting as the outlet of the air curtain. That means the air curtain will be recirculating through this region. And then this is the atmospheric outlet. Through this we need to compute the heat transfer. If the heat transfer is taking place too much, that means the air barrier effectiveness is very less. So these are the name selection that we need to provide before getting into the simulation. And the very important thing is the mesh size. So we have to select a mesh size. I have did the mesh sensitivity analysis already, so I have kept that 60 mm as the mesh size here. And after creating this mesh, we can close that, and let's get into the Ansys Fluent setup and see what are the boundary conditions that we need to provide. Okay, in the recent versions of Ansys Fluent, we can see the boundaries by this geometric representation. We can see the outlet boundaries by having an arrows that is pointing outwards, and the inlet boundaries will be having a symbol by an arrow that is pointing inwards. And let's see the general setting. We have to switch that to transient because we need a time dependent analysis, because as the time goes up, the room will be cooled down and the atmosphere hot conditions will be getting in, and a phenomena that should be studied in a time dependent manner. So we are enabling the transient option, and gravity should be enabled so that the buoyancy flow, that is the flow that is causing because of the density difference, that will be simulated if you enable this gravity and give the acceleration in the y direction as minus 9.81 to give the actual case as the Earth's gravitational acceleration. Coming to the model, by default the energy option will not be enabled, so we have to switch on energy model, because energy model enables us to give the temperature and heat flux and everything. And coming to the viscous model, by default in the previous versions of Ansys Fluent, there will be the laminar model will be kept as default model, but that is not appropriate for this type of simulation, so we have to go for any turbulence models accordingly. In recent versions of Ansys Fluent, this transition SST equation is used. If you want to use that equation, you can proceed with that. I have changed that to k omega 2 equation model in order to have a simplified model. And then coming to the materials, air will be a default material in this Ansys Fluent, so we need not to change that. Let's keep that air as the default material and let's use that air as it is. And go to the cell zone conditions. We have only one zone, that is surface body, that will be filled with air. So the boundary condition is a very important thing is here. So we have inlets, these two are inlets and this is outlet, but however these are not simply inlets, because these are recirculation zones, because an air conditioning system receives the air from the room and then it cools that, and again it will send that to the room again. So that is actually a recirculation boundary. Similarly here we have a boundary, that is air curtain inlet, that is also a recirculation boundary, because the air is not coming out from the system entirely. The air is drawn from this room and then it is compressed and then it is blown inside the room. So we need to have a recirculation boundary. By default there is no recirculation boundaries in Ansys Fluent, so for that we have to use that text user interface. I have found that somewhere in the website. Just copy this thing and paste that in your console, that is this space. In this console, if you paste that code, the recirculation boundary will be enabled. If you right click any boundary and if you see the type, there will be recirculation inlet and recirculation outlet. So this will be enabled only if you give that code in this particular console. So here in our case, inlet 1 and 2 are the recirculation inlet. This corresponds to the air conditioning system. So in the air conditioning system, one more thing is essential, that is the air should be cooled before getting into the room. That is the main thing of an air conditioning system, that is done by an external air conditioning unit. Here we have to simulate that by giving a heat source of some value. Actually this value should be in negative. So if we give some value of minus 3000 watts of heat source, that means that much of heat will be extracted from the air so that the air will be getting cooled. So this is one boundary that we have to use here. Similarly at the inlet 2. And air curtain inlet is also a recirculation inlet. Here we need not to have any heat source, because air curtains generally do not deal with any temperature difference and heat flux and everything. And coming to the outlets, the atmospheric outlet is the boundary that we have kept here. So I have specified that simply as an pressure outlet with an atmospheric pressure, that means the gauge pressure is 0. And then the curtain outlet is actually defined as a recirculation outlet. So in the recirculation outlets, we have to give the mass flow rate or otherwise the mass flux. So according to that, according to the outlet boundaries, the inlet flow rate is calculated, because at the inlet we haven't specified any flow rate or mass flow rate or velocity or anything. So that will be recirculated based on the outlet condition. So at the outlet we need to specify the flow rate we have 3 inlets. These 2 are the inlets of air conditioning system, and this is the inlet of the air curtain. Similarly, we have 3 outlets. One is the outlet for the air curtain, another one is outlet for the air conditioning system, and another one is the atmospheric interface. And then we can go to the solution phase. And before running the solution, we have to initialize. So after initializing the system, we have to patch this. The patching is done actually to specify the initial temperature or initial condition of this thing. So we have to patch the entire surface body by a temperature of 30 or 35 degrees Celsius according to the condition. When the cool air gets in, it will be cooling down from this particular temperature. Give the patch and then you can run the calculation. So if you simply run the calculation will be performed, and we cannot get the contour plots for each and every time step. So for that we have to keep a monitor, or I prefer to set the report files. So I need to have the heat flux. So I have to create a heat flux. So I can give a new heat transfer rates through the atmospheric outlet. So this is the atmospheric outlet. So through this particular outlet I need to compute the heat transfer. This is the report definition where we have kept the heat transfer rate. So these two things will be accounted here in this case, and if we click OK, and the report file will be generated based on the details what we have given. And the most important thing to visualize that is we have to set the contour plots. So for that I generally prefer the text user interface. So I have some predefined some text commands for that. Let me show you that. So these are the text commands generally I use for visualizing the plots. So using these plots, these commands will generate the plots of the temperature or velocity or turbulence, whatever, on each and every time step, and those images will be saved in the location of the workbench. So here I have all these images. So after running the simulation you will be getting the plots like this. So each and every time step these files will be saved. As an animation you can get the actual plot. So these are actually images. These can be converted into animation by using some from conversion softwares. So once you set this code, once you decide these codes, and you have to place these codes in this calculation activities, there is an option called execute command. Go to the execute command and define that command. So create a new command and just paste the text user code here. And these commands will be executed each and every iteration, not iteration, it has to change to be time step. So for each and every time step these commands will be executed. What this command will do, this will set a new window, and also it will set the picture resolution. That's the main intention of using this text user interface. We can have a control over the pixels of this plots, and then we have to set the velocity magnitude, and we can give the fixed range for that, and that will be saved by this name. And once you give this command and click OK, and if you start calculating, it will calculate all the values based whatever we have given in the commands each and every time step, and that will be saved as the images as I shown you earlier. And finally you can combine these images to have an animation. I hope this tutorial helped you. If you have any doubts or clarification, please feel free to contact me. Thank you.